Hi everybody, here's the solution set to problem 1 on your extra problems. So the dean of a particular college was concerned about campus safety. He commissioned a study and surveyed 400 students. Of that group of 400, 28 of them carried a weapon, gun, knife, or calculator. The dean claims that less than 10% of the students carry weapons. Test that claim. Let alpha equal 0.01. Alright, so we have test that claim. That tells me I'm going to use the 4-step procedure for testing hypothesis. Then how do I know what to set up? Well, we have less than 10%. So the less than points us to less than in our H1. The percent tells us we're dealing with proportions. So we're going to have, in step 1, HO P greater than or equal to 0.10 versus H1 P less than 0.10. Alright, our test statistic, for these, you have to get the sample proportion first of all, and you get that by taking the number of successes, success being a relative concept. In this particular case, it's going to be the number carrying weapons over the total number of students surveyed. So it's 28 over 400. That gives me 0.07. Then, here's the formula for the rest of the test statistic. You've got p hat minus p sub 0. And the p sub 0 is just the number value in the hypothesis, over the square root of p sub 0 times 1 minus p sub 0 over n. So you have 0.07 minus 0.10 over the square root of 0.10 times 1 minus 0.10 over 400. That gives me negative 0.03 in the roof over 0.015 in the basement. So that gives me a test statistic of -2. Alright, so let's look at our rejection region. Whenever we have a one-sided problem like we do here, you're going to take 0.5 minus alpha, and that's 0.5 minus 0.01, excuse me, which equals 0.4900, and the z that's attached to that is 2.33. So then we set up our if-then. If z star is less than negative 2.33, then we reject HO. We use the negative because the alpha level is going to the left because it's a less than. So that's why you have less than negative 2.33. We're comparing that against -2, so we fail to reject HO.